In this video, I'm using the data file D5 to run a one-way analysis of variance, one-way ANOVA, where the assumption of equality of variances is violated. This is just a follow-up video to my previous video. Please watch my previous video on two-way analysis of variance, where I explained all aspects of ANOVA and in interpretation and reporting when the assumption of equality of variances is not violated. So in this data set, I have satisfaction, which is a continuous variable. It's my outcome, and two aspects of the product, size and color. We are going to use only size. This is a one-way analysis of variance. So one independent variable, it has three levels: small, medium, and large. So as I explained in the previous video, analyze general linear model, univariate. Satisfaction goes here and size goes here. In order to get the homogeneity test, we click on this option, continue. Okay. So this table gives you information about the Levene's test of equality of variances. And as you can see, this is significant. This is telling us that the assumption of equality of variances is violated. Then we can conclude that the error variances are not equal across the groups. So this F value is not very reliable. What should we do when the equality of error variances cannot be assumed? Now, in this context, we only have one independent variable. So I'm going to demonstrate what to do if you only have one independent variable. There are a couple of options. Today, I will focus on two of them. The first one is to do a non-parametric test. Analyze non-parametric test, K independent samples. Satisfaction goes here, and size goes to the grouping variable box. And the range is from 1 to 3. So here I type 1 and 3, continue. You can get also descriptives. Continue. And we are interested in Kruskal-Wallis non-parametric test. Okay, so this is the typical ANOVA test, but we are interested in the Kruskal-Wallis test. And you see the F value, the typical F value is significant. It's smaller than 0.05. And the Kruskal-Wallis test is also significant with 2 degrees of freedom. And this is the H value, which is statistically significant. So we can conclude that there is at least one difference between the levels of the independent variable, small, medium, and large. So at least one of these are statistically different from another one. So this is one way. Instead of relying on the typical F value, we use Kruskal-Wallis test. Another option, if the quality of error variances cannot be assumed, is to go to analyze, compare means, one-way ANOVA. Satisfaction goes here, and size goes here. Options: Brown-Forsythe test and Welch test. These two provide a correction for our F test. And also, it's good to get the homogeneity of variance test plus descriptives. Continue. Okay. So again, you see that the test of homogeneity of variances is significant, so that cannot be assumed. This is your typical ANOVA table. This is the typical F value, but we are more interested in robust tests of equality of means. Here we have Welch test and Brown-Forsythe test. Both of them are significant. Sometimes they are very different from each other, so you can choose the more conservative one. But sometimes they are consistent with each other. In this case, both of them. So we are using these two corrections, and both of them are telling us that there is actually at least one significant difference between the three levels of the independent variable. Okay, this option is more attractive than the first option, non-parametric test, because here you can do a follow-up post hoc test. So analyze, compare means, one-way ANOVA. You keep everything as it is, but you can click on post hoc. And here you have a number of post hoc test options for specifically when the equal variances cannot be assumed. And in this case, we need to choose one of these. And the most popular one is Games-Howell. So I take Games-Howell, continue, click OK. You get the same results, but this time you get pairwise comparisons using Games-Howell test. And the two sides, is a small and medium, are not statistically different from each other in terms of satisfaction, but small and large are significantly different in terms of satisfaction. What about medium and large? Statistically significant. Now let's do it in JASP. In JASP, click on ANOVA. ANOVA satisfaction goes to dependent variable, and size goes to fixed factor box. You can request for descriptive statistics, estimates of effect size, and all of these options here. But again, you can check homogeneity of variances by clicking on this. And as you can see, it's significant. So you cannot assume equality of variances. Then, very conveniently, you can choose Brown-Forsythe and Welch corrections here. And when you choose these two options, you get, so this is the typical F value, the typical ANOVA. Then you have Brown-Forsythe and Welch corrections here. And again, you see that all three consistently say that there is at least one significant difference between the levels of your independent variable. And you can follow it up by looking at post hoc tests. I send size to this box and choose Games-Howell and unchoose Tukey. So this is a table related to Games-Howell. You can see the pairwise comparisons. So this was the option where you use corrections, Welch and Brown-Forsythe corrections. The first option was to use non-parametric tests. And you can get that here by clicking on non-parametrics. Send size to this box. And then you get the Kruskal-Wallis test here, which shows that, which is consistent with the results of typical ANOVA and Brown-Forsythe and Welch corrections. All of them, they suggest that there is at least one significant difference between the levels of the independent variable in terms of satisfaction. And the post hoc test here gives us more detailed information on the differences between each pair of groups.